Okay, everyone. Please welcome our teacher, Sir Jet Tarot. Let's discuss now the ones present in your module, which is all about chemical bonding. No? Chemical bonding is present on the elements in the periodic table. How we created water, how we created, or not we, how our Mother Earth created water, how our Mother Earth created all the substances present in its being here on Earth is because of the bonding between different atoms that is present in every molecular structure of an of a substance of a said matter. In fact, we had chemical bonding way back when you were still grade 8. Did we not? Ionic and covalent bond. I'm not so sure. If my memory serves me right, did we have this in our grade
Yes,
8?
sir. Yes,
Yun.
sir.
So, I hope that this lesson is now going to be easy and understandable. Okay? Because our concern is already adhered way back when we are still grade 8. So, much like that, this is an easy discussion then. So, let's go back to what is the basis of bonding class. We will use the LEDs or the Lewis electron dot structure to signify the type of bond between a covalent bond to an ionic bond and not matched with a metallic bond. Lewis electron dot structure will tell us the number of electrons present in the outermost shell of an element. Lewis electron dot structure will be guided by the group number. If you have your periodic table with you, the periodic table tells us the group number in Roman numerals or in numbers. The group number will tell us the number of valence electron present in a certain element. For example, nitrogen. Nitrogen belongs to group 5. So, nitrogen contains 5 valence electrons. Oxygen belongs to group 6. So, therefore, oxygen belongs to, so therefore, oxygen has 8 valence electrons. Lithium belongs to group 1, so therefore lithium contains 1 valence electrons. But if we talk about the elements present under the noble gases column, neon belongs to group 8. So how many valence electrons are there present in neon? Van. If neon belongs to group 8, so how many valence electrons are there present in neon? Still 8. Okay, again, the group number tells us of the valence electrons present in that said um, presence in that said element. However, with respect to ionization, neon contains an ionization of 0. It is not a positive ion nor a negative ion because all the noble gases are already stable at 8 valence electrons. Talking about stability at 8 valence electrons, that is the target of chemical bonding. Okay? That is the target of chemical bonding. To achieve stability, one element must contain 8 valence electrons, except for hydrogen and helium. For it to be stable, they should contain 2 valence electrons because being a member of period 1, it only contains one outer shell and the first outer shell of an element will only contain 2 electrons to be stable. That is in the s orbital, no? So the SPDF orbital, something like that. Or the electron configuration, SPDF. For those who are turning on their cameras, wala akong nakitang ganun. So, sige na lang. Let's proceed. Okay, so cations are positive ions. How come an ion becomes a cation and an anion becomes a negative ion? Or how comes an anion becomes an anion and a cation becomes a cation? Speaking of cations, they are positive ions and the anions are the negative excuse me, negative ions. If you look at your periodic table class, the bottom portion of your periodic table contains the cations and the anions or the charges of the molecules. But with respect to the elements class, when can you say that the element is a positive ion and when can you say that the element contains a negative ion? For example, what is the ionization of beryllium? Is beryllium a positive ion or is a beryllium a negative ion? Al. Al Nicolasora. Is beryllium a positive ion or is beryllium a negative ion?
Bisa? Bisa, sir.
If you look at the periodic table while Al is looking for the answer, if you look at the periodic table class, you notice there the ionization. The ionization is represented by the +2 or the -2 or the +1 and the -1. That will tell you that that element is a cation or that element is an anion. Okay, for example, beryllium here, the ionization of beryllium is +2. And then if you compare that to oxygen, the ionization of oxygen is -2. How many how many electrons are there present in beryllium? How many electrons are present in beryllium? Catherine. How many electrons are present in beryllium?
I don't have from my periodic table, sir. May I get some?
Okay. Wait. I'll give you the atomic number. Beryllium with atomic number of 4 and mass number of 9. Again, beryllium with atomic number of 4 and a mass of 9.01.
4, sir.
4. Very good. So the atomic number of an element will determine the number of protons and the number of electrons. Remember? So the number of protons of an element is the same as the number of electrons. So if beryllium is element number 4 with the atomic number of 4, then beryllium contains 4 protons and 4 electrons. But why is it that beryllium is +2? Why is it that the ionization of beryllium is +2? So let me write it here. Beryllium is +2. If this beryllium will participate in a chemical bonding with oxygen with the ionization of -2, the idea of it is that beryllium with 1, 2 outer shells and 4 electrons, the idea to achieve let's put it this way, to achieve stability class, beryllium will just simply share or rather give off its 2 valence electrons. So by the time it will be given to oxygen, therefore oxygen receives 2 more electrons, beryllium loses 2 electrons. So if you look at it closely in a table class, for beryllium to achieve the ionization of +2, if you look at the number of electrons and protons, beryllium now contains 2 electrons and 4 protons. That is why beryllium is slightly positive since it has 2 electrons lost during the chemical bonding. So the presence of 4 electrons makes beryllium positive. But why is it that oxygen is -2 in its ionization? Beryllium, rather, oxygen with a -2 means that the atomic number of oxygen, by the way, is 8. So the number of protons of oxygen is 8. But by the time it will participate in a chemical bonding, oxygen will receive 2 electrons. Therefore, oxygen is slightly negative and it has 2 more electrons than protons. That is why oxygen is slightly negative with the ionization of +2. Get it? The other way of understanding ionization class is the fact that in a certain element, let us say element A, and this is oxygen, I will not use O because we're going to use an outer shell here. If element A contains an atomic number of 8, then the outermost shell contains 6 valence electrons. Di ba? 1, 2, 3, 4, 5, 6. To achieve stability, the outermost shell should contain 8 electrons, right? But in this case, element A contains 6 electrons only. So it needs 2 more electrons for this element to achieve stability. We call this as the octet rule. That is why element A needs 2 more electrons, making element A, if it will receive an electron, the ionization there is negative. Okay? So let's understand it further, class, para when we discuss this lesson, mabutang yun sa ato ang heart ang ionization. So the ionization +2 means that it will lose 2 electrons. The ionization of oxygen, which is -2, means that it will gain or receive 2 electrons. See the irony of the sign? Plus, but it will lose. Minus, but it will gain. It doesn't mean that -2, you subtract 2, or +2, you add 2, but the idea of the ionization is because of the sign of what is lost or gained in the said chemical equation. Okay? I am talking of ionization because the first type of bonding that we're going to deal right now is ionic bond. Okay? Ionic bond is present between metals and non-metals. You cannot create an ionic bond between two non-metals. You will only create an ionic bond to a metal to a non-metal. Example, lithium and oxygen, calcium and chlorine. But you cannot create an ionic bond to hydrogen and oxygen because hydrogen, even if it belongs to group 1, hydrogen is a non-metal. Okay? You cannot create an ionic bond to phosphorus and sulfur because phosphorus and sulfur are non-metals. Okay? What about metalloids, sir? Class, metalloids may appear metal in its natural setting, but they behave like a non-metal. Still, you cannot create an ionic bond between a metalloid to a non-metal. The existing bond there is covalent bond, but that is true to a polar covalent bond between a metalloid and a non-metal. What is the type of structure that is present in an ionic bond? It will create a crystal lattice or a lattice structure. A lattice structure could either be pyramidal, um, square planar, um, um, octahedral. These structures will be the basis of how a bond under covalent bond becomes will be named according to their structure. The physical state of an ionic bond after the bond is being made is a solid. The melting point is high, solubility of water is present. Example of it is sodium and chlorine, creating sodium chloride, which is rock salt. It is soluble in water. If there is an electrical conductivity, the answer is a yes. And if the other properties are present, then there are no other properties. So ionic bond, let's further go to ionic bond class. If ionic bond exists between a metal and a non-metal, what happens to the electrons for this type of bond? The electrons in an ionic bond will transfer. And what will transfer? It's like it's like the metal will give its valence electron to the non-metal. No, that is the idea of transfer. It will give off their valence electron present in the said outer shell, so that both metal and non-metal will achieve the so-called octet rule. And these metals being able to give an electron will become slightly positive, and these non-metals to receive an electron will become slightly negative. Thus, the names exist as cation and anion. I think we show the transfer of electrons with an arrow by the time we show the LEDs, right? Okay, let's have an illustration here, class. This one. Here. Let's try to show the ionic bond that exists between potassium and fluorine. Potassium with group number 1 has 1 valence electron, and fluorine group number 7 with 7 valence electron. Potassium being a metal which will react with fluorine, a non-metal, it will create an ionic bond. Therefore, potassium in an ionic bond will transfer its valence electron to fluorine. So the symbol that we used beforehand in the grade 8 is an arrow to the non-metal. And this is also the same case as when we are going to have this in a summative test. Speaking of summative test, class, in ST5 of mathematics, I purposely wanted you to pass your answer sheet. It is because writing a fraction in Edmodo is quite hard, especially that our denominator contains a binomial. No? When I checked, and when I was about to check the paper of Ken Robertson, I marked some of his answers wrong. Why is that so? It is because, if I may show it here for a while. Why I did mark the answer of Ken Robertson wrong at some point? The initial checking before seeing that most of your answers are like that. So if, for example, 1 over x plus 2. I marked this answer as wrong. Why is that so? Because the denominator is just x, excluding 2 in this expression. Para bang, if I were to rewrite this expression, this is just equal to 1 over x plus 2. You get my point? So it should be that if you're going to write a polynomial fraction, it should be 1 over x plus 2. That is supposed to be how you are going to write that in Edmodo, so that I will treat the answer as 1 over x plus 2. See the difference? So when I realize it as a problem that will be carried out in writing your final answer, I put that in the instruction. Place all your answers in a paper, picture your answer, and send it in Edmodo or ano. But then again, the others were able to generate answers directly in Edmodo. So I'll just consider the answer of Robertson. So I recheck his answer, and it was then correct. No, it's just that how it was written perhaps was it was wrongly done in Edmodo. In Edmodo. But if we can do that in Microsoft Word, I think we can do it properly then. Going back to this one, class. So when we're going to have a potential exam in ionic band, make sure that when you show an ionic band, the symbol that you're going to use is an arrow, whether a straight line or a curved line, directing the electron of the metal to the non-metal. Okay? So it's like giving the electron of potassium to fluorine. This is something like that. So potassium now becomes positive 1 and fluorine becomes negative 1 because of the presence of 1 extra electron given by potassium to fluorine. So it is now slightly negative. And for potassium to lose 1 electron, so the potassium becomes slightly positive, making potassium a positive ion and fluorine a negative ion. So the the bond that exists between these two is an ionic bond. Question regarding ionic bond. Okay, none. Let's proceed. The second type of bond is metallic bond. Metallic bond is present among metals. An example of which is an alloy. An alloy is a combination of two metals. So that's metallic bond. Metallic bond, the electrons present in a metallic bond is actually it's like a bed with each corner contains all the electrons and it is arranged accordingly. The type of structure present in a metallic band is what we call as the sea of electrons or an electron sea. And it is really having a definite shape and a definite placement in between two protons, the electrons. The presence of metal as well gives us the state of metallic band as solid, and the melting point is very high. You cannot melt a metal at 100 degrees Celsius, but it is at a higher level. Solubility of water is impossible. You cannot dissolve a spoon in a water. No? But the electrical conductivity is very high except for poor conductors of electricity. There are some metals which are poor conductors of electricity, no? Making them insulators. But the general picture of a metal, they are good conductors of electricity. Other properties, you can consider that as a malleable, ductile, and lustrous for metals. When I talk about sea of electrons class, mo nang dagway sa sea of electrons. There's a lattice structure of the solid atoms, wherein each of the corners in the solid atoms presents are the electrons. And they're like, ano tawag dito? In a book that I saw, upon looking at the structure of a metallic bond, it's really in a parang isa-isa kada corner of the structure of the atoms of the solid. Okay, so that is metallic bond. The third type of bond is what we call as covalent bond. Covalent bond exists between two non-metals. Again, covalent bond exists between two non-metals. Covalent bonding shares their electrons. If ionic bond transfers an electron to the non-metal, so to achieve the octet rule, in a covalent bond, it shares an electron. The sharing of electrons is showcased by the line segment that joins the lone pairs of one element to another. Covalent bond has an attractive force due to the sharing of electrons. Okay, so we have here an example of covalent bond. So these are the most active nonmetals are the halogens, which will ask for one electron from the alkali earth metals in an ionic bond. But in a covalent bond, every nonmetals are highly active with one another, depending on what metal will combine to another. Okay. So in addition to groups 4, 5, 6, and 7, hydrogen participates in the covalent bond, covalent bonding. Covalent bonding could either be single, double, or triple bond. Example of double bond that exists is the molecules of oxygen. For triple bond, the molecules of nitrogen. Now we will have that as an example later, if we can find some time. But for a single bond, let's try to use chlorine molecules class or chlorine atoms. Let's try chlorine. Here. To achieve the octet rule, to achieve the stability between the two chlorine atoms, the first chlorine needs one electron and the other chlorine needs one more electron. Instead of transferring one electron to the other chlorine, the two of them decided, let's just share our electrons. So to achieve the octet rule. Thus, the first chlorine is complete at 8 valence electrons, and the other chlorine is also present or is also achieving the octet rule at 8 valence electron. And the bonding that exists between them is a single bond. Pwede mo na nato higdaon that will create a line segment. And we can do it in this way. Ayun, single bond. So from there, we can generate a line segment that connects to from one chlorine to the other. And this is a single bond between two chlorine atoms. In the ionic bond, that's the arrowhead. There's an arrowhead. Whether straight or not straight, there should be the presence of the arrowhead to signify that in an ionic bond, there is a transfer of electrons. But in covalent bond, you just have to draw a line segment showcasing the sharing of electrons between two different elements or two separate elements. Let's now showcase a double bond. Okay, na siya. Oxygen. Oxygen contains 6 valence electrons. So to achieve its stability at the octet rule to have 8 valence electrons, it must contain 2 more electrons. But since the other pair is also an oxygen with 2 more electrons needed to achieve the octet rule, so they decided that they will share their lone pairs. So that we have one bond generated by the first lone pair, and then another bond for the next pair. So there you have the bonding between oxygen. To achieve the octet rule at 8 valence electron, we have the sharing of atoms. And you look at the sharing class, dalawa yung nakita natin. Dalawa yung nagagawa nating sharing. Therefore, this type of bond is known as a double bond. Ano yung gitawag na tuog? Double bond. So we can show the double bond between two oxygen atoms in this manner. Para bang 0 equals 0. Yung ganun. No? Or para siyang emoji. If Kent Bollinger will make a no look pass. Ganun ba? No look pass. Yeah. Okay, so we have here the two dashes that signifies the double bond class. For nitrogen, we can generate a triple bond between nitrogen class. Allow me to draw nitrogen here. So nitrogen with 5 valence electrons, right? So we have one. Let me choose another color. 1, 2, 3, 4, 5. And then the other nitrogen with 5 valence electrons as well. 1, 2, 3, 4, 5. So this is the triple bond. 1, 2, 3. So for the first nitrogen, you have 8 valence electrons. 2, 4, 6, 8. And the second nitrogen to have 8 valence electrons as well. 2, 4, 6, 8. So this is sharing of electrons between two similar atoms. This exists because nitrogen, oxygen, fluorine, bromine are what we call as diatomic elements. If they appear alone in the atmosphere, they should be having the symbol O2 because these elements are called diatomic in nature. Hydrogen is diatomic. Fluorine is diatomic. Chlorine is diatomic. Bromine is diatomic. Okay? 7 man sila tanan. Hydrogen, chlorine, fluorine, bromine, iodine, and 246, astatine. Astatine is 80. Yeah. These are diatomic in nature. So if we are going to proceed with chemical bonding, let's say hydrogen, let me use a red. If we have hydrogen plus oxygen equals water, this is not this is not a correct answer. Rather, this is a wrong notation class. So since these are diatomic elements, so we have hydrogen plus oxygen. So H2 plus O2 equals H2O. And then we just have to balance it with a number to multiply the molecules. So this is 2 molecules of water is generated by 2 molecules of hydrogen and 1 molecule of oxygen. So in other words, kung drawing ko na to na siya, mo ni si hydrogen, then mo ni si oxygen dere, si oxygen dere. So if we are going to create a molecular formula or structure, this will be the looks of it. Oxygen with 2 hydrogens. Diba mo man na siya ang molecule sa water? Something like. This is now the evidence of the 2-1-1, 2-1-2 rather, 2-1-2, 2-1, and then 2. Duha ka molecule dire. How will you name the molecule of water? How will you name H2O? If CO2 is carbon dioxide, how will you name H2O? Just as plain as water. You cannot name it as dihydrogen oxide. It's just simply water. You cannot name it as such. Na? Sir, can I name it as dihydrogen oxide? The answer is a no. How about this one, class? I think this one is intriguing as well. How will you give a name to this one? H2O2. If H2O is water, this is water. What is H2O2? This is read as nani sa tambal sa mga tambal bitaw sa mga samad. Agua oxygenada. What is that one? Hydrogen peroxide. Hydrogen peroxide. Although it's not named according to the subscript, but this is read as hydrogen peroxide, most commonly known as agua oxygenada. Okay, let's proceed. So those are the 3 types of types of bond class. Metallic bond, 2 metals joined at each other. Covalent bond, 2 nonmetals. And then ionic bond, a metal to a non-metal. The text in the slide are probably some vocabularies regarding the types of bond. So here is an example of a covalent bond. A carbon and an oxygen are both nonmetals. Ionic bond, sodium is metal, chlorine is nonmetal. Let's now complete the table a while ago, class, when we discussed the ionic bond. So the type of bond present in an ionic bond is a transfer of electrons between metal to nonmetal. For covalent bond, this is sharing of electrons between 2 nonmetals. The type of structure in an ionic bond is a crystal lattice, but in a covalent bond, it's just a simple illustration of a molecules. In the near future, this covalent bond will be drawn in a structural formula. These are the 3 formulas for a covalent bond: molecular formula, empirical formula, and structural formula. And the structural formula signifies the true nucleus or the true molecules of the covalent bond. For a covalent bond, for an ionic bond to have a physical state of a solid, covalent bond could either be liquid or gas. Melting point for ionic is high, melting point for a covalent bond is low. If you compare salt and water, water boils first, followed by salt. Okay, that is why evaporation is the best way to eliminate the components of salt water, leaving the salt contents, because the boiling point of water is low, whereas the boiling point of salt is high. So if you increase the boiling point at 100 degrees Celsius, water will evaporate, leaving the solid crystals. But if you increase the temperature more than 100 degrees, perhaps you'll see fragments of the burnt chemical composition of the salt. Then we have solubility in water. For ionic bond, it is soluble. For covalent bond, probably usually not. Na? Sometimes two liquids are immiscible, that they cannot be mixed with each other. Example is an oil and water. They are immiscible. Electrical conductivity for ionic bond, it's a yes. For covalent bond, it's a no. And for other properties, they don't have other properties except for metallic bond, wherein we have ductility, malleability, lustrous, transparency, um, um, crystalline structure, odor, texture, daghan. In a metallic band, there are a lot of properties in a metallic band. What was mentioned in the previous slide was just three: malleable, ductile, and lustrous. Never mind with the next. Ano. Remember atoms, diatomic molecules. So these, the 7 diatomic molecules, remember this one. C if bron. CFH bron. C is chlorine, I is iodine, F is fluorine, H is hydrogen, Br is bromine, O is nitrogen, O is oxygen rather, and N is nitrogen. CFH bron. So these are the 7 diatomic molecules. Or you can memorize the elements in the halogens group. All the halogens, including hydrogen and oxygen and nitrogen, are diatomic in nature. Okay. So you look at your journal entries carefully. Types of formulas. We'll just have to discuss this in our next lesson, probably in the second quarter, as we move forward with naming the molecules. How to name the following molecules given the empirical formula and the molecular formula. Let's proceed with bond polarity class. Since we're talking about covalent bonds, the polarities of a covalent bond exist either polar or non-polar, depending on the differences between their electronegativity. How will you find the electronegativity in the periodic table class? Look closely to the values. I don't know if you can see that from here. Let's try. Let's try. Um, yeah. You can see the electronegativity word. It's the bottommost portion of the picture that I saw. And it is in this area, the bottommost value of the element in the periodic table. So if that element has the values from the top, which is the atomic mass, down to the bottom, the last value there is the electronegativity. Okay? So we have there the atomic weight, ionization, oxidation, melting point, boiling point, density. The last value there is the electronegativity. For hydrogen, you have the electronegativity of 2.1. For it to become ionic under covalent bond, the electronegativity is greater than 2. For it to be nonpolar, the electronegativity should be less than 0.2 or 0.2.5. That's less than. Between 2.5 and 2, that is polar covalent. Sir, do we have an ionic bond in a polar covalent bond? This ionic class here, the idea of this kining ionic class is that the bond is covalent, but it exhibits an ionic behavior because of the high polarity uh, between the two elements present or more elements present in the compound. Still, it's covalent, but it showcases an ionic behavior. But still, that is in the covalent band. Sir, do we have to know the if sodium chloride is polar or non-polar? The answer is a no. Because sodium is already a solid, or rather a metal, so this is understood to be in the ionic band. You will only determine if it is polar, non-polar, or ionic if it is covalent band. And what is covalent band? Two non-metals. First things first, how will you know between it being polar covalent or non-polar covalent? Subtract the electronegativity. Subtract their electronegativity class. If it is polar, there's an equal sharing of electronegativity. Electronegativity is how strong your elements are. Depending on how many electrons are present in the outermost shell, we call that the lone pairs. That's the strength of that said element. We determine it by we determine it with the term electronegativity. Okay. Since polar covalent is sharing, so there's a high chance that the two of them gets to drag. There's a dragging force between the sharing of the electrons. For example, water. Let's try water. The molecule of water is H2O, right? So we have here oxygen and hydrogen. And then covalence, yeah. But take note that oxygen contains 6 valence electrons. So we have 1, 2, 3, 4, 5, 6. Diba? This is the fifth and the sixth. And then these are the mao ni ang gitawag na to og lone pairs class. Sige kog mention of lone pairs. Mao ni ang gitawag na to og lone pairs. Okay, lone pairs means they are present in the molecule without sharing or transferring of the electrons to the other partner molecule. This is the bond that exists between hydrogen and oxygen, which is covalent. But in this structure class, you notice that oxygen is slightly strong in its pulling force, which happens to be in the electrons present in the lone pairs. Therefore, the shape of the molecule of water is slightly bent. So the shape here is bent. To further classify, this is actually polar covalent. So to illustrate the electronegativity, we have the dipole like that. No? This one is slightly negative, the tail is slightly positive. So ang dipole na to padung dito. Something like that. But then again, this might sound confusing, so let's go with the electronegativity difference. The electronegativity difference starts with the electronegativity of oxygen is 3.5 and the electronegativity of hydrogen is 2.1 and the difference there is 1.4. So it is greater than 0.2. It is in the range of polar covalent. Therefore, water is polar covalent and the shape is slightly bent. Sounds confusing. I suggest after our discussion, if it is still a confusing class, there are a lot of videos in YouTube that we can refer into. And I know for sure that you are diligent enough in looking at the videos in YouTube, especially if there's a new update of an episode of the manga you are watching in, or the anime you are following. So include that in your ano no, searching the polarity of the covalent bond. This one is the dipole that I referred to a while ago, class. Slightly positive and slightly negative. So the structure there is a little bit stronger to the slightly negative because of the presence of more electrons. So there is a higher electronegativity between these molecules. The more valence electrons of an element, the stronger the electronegativity of that molecule. Okay, but the but the but the increase in the outer shell declines or reduces the strength of the electronegativity of the molecule. Perhaps if you consider that the structure of the periodic table, the highest electronegativity falls on fluorine. No? Fluorine has the highest electronegativity. The most electronegative molecules are fluorine, oxygen, chlorine, nitrogen. Yung mga in. polar covalent bond, non-polar covalent bond, and ionic bond. So notice the ionic bond class, the presence of the positive and the negative ions. But when you talk about the polarity of covalent bond as non-polar and polar, uh, in a certain shape, there is no greater polarity on either of the sides of the molecule. So therefore, this is non-polar. But if there's a high chance that one side is bigger than the other, then this is polar. Non-polar, polar. Na stronger side ang polar. Ang non-polar, there's an equal distribution of electronegativity. To be specific, the very nonpolar molecule is our diatomic elements, O2, N2, H2, F2, and the likes. Because there's an equal sharing of electronegativity, or the difference in its electronegativity is 0. Electronegativity is the attraction of an atom that has for the shared pair electrons. The higher the electronegativity, the more electrons it is present in the atom. So here is an example of a polar covalent bond, muriatic acid or HCl. This is the electronegativity trend class. As the molecules or the elements go up, the electronegativity increases. As the molecules move to the right, the electronegativity increases. Additional information for an ionic polar covalent bond which exhibits an ionic behavior, the electronegativity is greater than 2. For polar covalent, the electronegativity ranges from 0.5, not 0.25 pala class, it's 0.5 to 2.0. But for non-polar, it's less than 0.5. Please change the info because I mentioned a while ago 0.25. It's not 0.25, but it's 0.5. So within the range of 0.5 to 2, that is polar covalent. Notice the difference of water at the difference of water at um, 1.4. It falls under the range of 0.5 to 2. So the molecule of water is exhibiting a polar covalent bond. Then the shape is slightly bent. So we have here boron and carbon. Boron is a metalloid but exhibits non-metal behavior. So this is a covalent bond. And the electronegativity of boron is 2.04. Carbon is 2.5. So the difference is this is nitrogen and silicon. So what is the bond that exists between boron and carbon? If you subtract 2.55 by 2.04, but in the periodic table, carbon is 2.5, boron is 2.0. The difference is 0.5, right? So therefore, it is polar because the range of values for being non-polar is less than 0.5. If it is equal to 0.5, that is already polar. But if it is less than 0.5, which is 0.49, that is already non-polar. How about carbon and nitrogen? Polar, non-polar? The answer is polar. Boron and silicon. 1.9 minus 0.4 is 0.06. 0.06 ba? So that is already polar. So which of these bond, the question is, which of these bond is least polar? Speaking of the electronegativity difference, the least polar here is carbon and nitrogen, no? The bond between carbon and nitrogen. Oh no, the question is which is least polar? So the answer is boron, tama ba? Least polar, which is more non-polar. What is the understanding of the question, class? Least polar. More polar, tama ba? More non-polar. So the answer is boron and silicon. Ano siya? Question? Let's try to look at the module. It's already 3:30 class, and I hope you understand our discussion for the chemical bonding. The way I see it, we cannot have a lot of exercises regarding the LEDs, but I hope that you can recall your discussions before in your grade 8 so as for us to understand the answers of the following. If you can secure your notebook, I think this is found in your notebook class, in the grade 8 notebook. So, makita niyo yung grade 8 notebook, pangita ato. Naray answer tanan ito na dire. Okay? So, it's already 3:30 and I hope you understand our lesson. Please have your modules answered. By Thursday, we're going to check your work.